so now we are going to go over Kahn's algorithm on the graph. I went ahead and drew the graph from our direct acyclic graph example from the slides on the board. So now we're going to do Kahn's algorithm on that to show us how do we get a topological sort. Okay, so first thing we have to do is we've created our output list, right, L, and then we are going to go ahead and make our set. Right, and this set is all the nodes with an in degree of 0, all the nodes with no incoming edges. For instance, 4 has an in degree of 3 because there's 3 edges incoming to it. And what would its out degree be then? Right, you've not heard that term before, but I think you can guess since there's 2 edges coming out of it. Right, its out degree is 2. Right, 3 has an in degree and an out degree of 1. Right, so here node 0 is the only node here with an in degree of 0. Okay, and so Kahn's algorithm works fairly straightforwardly, right? Which is that while this set is not empty, remove this from the set, and then add it to our output, and remove it from the graph. And by removing it from the graph, we're also going to remove the edges from this graph as well, right? So we remove all the edges that 0 had output, right? We had an edge from 0 to 1, 0 to 4, and 0 to 3. So those are now gone. So now we reevaluate which nodes have no edges, now have an in degree of 0, which have no incoming edges. 1 and 3, right? So, okay, so now we go ahead and we will just choose one node from our set S. It doesn't matter which one, right? And we will go ahead, and I'll go ahead and remove 1, add it to our output, and I will remove 1 and all of its out edges, right? 1 of all of its edges, right? So now let's go ahead and look. This is an in degree of 0, this has an in degree of 0, 1, 1, 2, 2, 2, right? So I'm going to go ahead and remove 3. Next, right? And that doesn't change our output at all, so we're going to go ahead and remove 2. And that will add, now 4 and 5 have an in degree of 0. Now we're going to go ahead and remove, let's say, 5. Again, it doesn't matter which ones we do. And then we're going to remove 4. Now we'll do the 6 and 7, and we can remove 6. And we can remove 7. And finally, we can remove, then 8 would be added to there. We could remove, then we add it to here, and we finally erase 8. And that's a valid topological sort for this graph. All right? So that was it.